Okay. Good morning. So, as usual on Mondays, we go through the homework problems. Uh, the first question, let us read it. Consider this function f of x to be x cubed minus 3x squared plus 1 on the interval, which is from minus 2 to 3, excluding minus 2 but including 3. Which option is correct? And as you see, all the options are talking about maximum and minimum of the function on this interval. For example, the first option tells you that f has a maximum on this interval, but not a minimum. The other option tells you that f has both maximum and minimum of this interval, and like this. So this, by just reading one or two options, you immediately realize the problem is talking about the maximum and minimum of a function on an interval. Yes, and that is the algorithm, hopefully you remember, which we also used in optimizations last time. So what should we do? We have to calculate the derivative of the function. So I'm just following the same algorithm that we had during the lesson, x cubed. And many of you are not doing the homeworks. Please do the homeworks if you are aiming for a higher grade, okay? Minus 2 less than x less than or equal to 3. The first thing that I will do, I will differentiate my function, which becomes 3x squared minus 6x. The second part of the algorithm is just to put the derivative equal to 0. So what I will do, I would say that 3x squared minus 6x equals to 0. The best way to solve this one is factorization because it is very simple. So I factored 3x out, x minus 2 is left, equals to 0. So then the product of these two numbers is equal to 0. It means that either the first one is equal to 0 or the second one is equal to 0. But then, of course, this means x is equal to 0 or x is equal to 2. But do you remember, in these kinds of problems, you have to be careful if you are supposed to accept them or not. How should I know that? I have to refer back to my interval. If these numbers are included in the interval, I will accept them. Otherwise, I just throw them away. Okay? So, but here, both of them are acceptable. So this one is acceptable. This one is also acceptable because both of them are within that range from minus 2 to 3. And then, do you remember what was that? Many of the students will confuse this algorithm with the algorithm we draw this long table, sine table. We don't need to do that when the interval is given. What I'm supposed to calculate, I am supposed to calculate the value of my function at these acceptable numbers and always two more points, the end points. Yes? And then compare the results. The maximum number that I get is maximum, the lowest one is minimum. So let us do that. So I will calculate, in this case, four numbers. F of 0, very simple. I replace x with 0, the answer is 1. Put these numbers in the box. The next one, f of this number, I calculate by putting 2 there. So it becomes 8 minus 12 plus 1 is what? Minus 3. Am I right? So I put 2 there. Yes? It becomes 8 minus 12 is minus 4 plus 1 minus 3. Yes? And then, what should I calculate now? F of minus 2. I put minus 2 there. So it becomes minus 8. And then again minus 12 plus 1, which is minus 19. I also need to calculate f of the other endpoint, f of 3. I put 3 there, so it becomes 27 minus 27 plus 1. Oh, sorry, plus 1. The answer is 1 again, because these two are cancelled. So this should be in the box. Yes? And now, be careful. The algorithm works for the case that this is also included. So there is one thing that you have to be careful. First of all, among these numbers, what is the maximum possible value? 1. Okay, and what is the minimum value? Is minus 19. But minus 19 is occurring where? One place. minus 19 is happening in one place. What is that place? Minus 2. Is minus 2 acceptable? No. So there is no minimum. Okay? So no minimum. Okay? But what is the maximum? The maximum number is 1. Is 1 acceptable? Yes, because first of all, 1 appears at 3, and 3 is acceptable. On the other hand, 1 also appears at 0, 0 is also acceptable. So which option we have to choose? No minimum and 1 maximum. So the maximum is 1. So this, if I go back to the options, which option I have to choose? F has a maximum on this interval but not minimum. Exactly, so I have to choose this option. Yes? But let me test your understanding. Let us say that I have given you this from the beginning. Do you think this will change?
No.
It will not change. Why? Because accidentally 1 appears at 2 places. 1, 3, 1, 0. Even if I exclude 3, still 1 has the chance to be attained, but this time where? At 0. Okay? So if it was this one from the very beginning, still the problem will be the same. Is that right? Yes or no? Okay, so that is the problem. You see, this algorithm is very simple, but there are some technical things you remember. The common mistake is people accidentally accept all the numbers. Of course, here, both numbers were in that interval, both of them you have to choose. But be careful. Sometimes some of the answers you get are not within your interval. Just throw them away. Okay? And then another common mistake is that people don't recognize this problem is asking about max and mean. They use the algorithm for local max and local mean. For local max and local mean, we have 2 algorithms. One algorithm which always is trustable and reliable is the first derivative test, the long method. And for the other one, we have another method which is called the second derivative test, but second derivative test has a weakness inherited in it, and that was the case if the second derivative is also 0, the test is not working. We have to go back and do the other. So there are some algorithms in this chapter, so you have to make sure that you really understand when to use which one of them. Okay, so that is good. Any questions? Okay, let us go to the next problem. So consider this function. It's a little bit lengthy exercise. I usually, when I give problems for the homework, I think that you have enough time to sit down and do the problems, okay? So consider this function. This is, you see, the number. By the way, in the national exam, you do not have these colors or italic forms, so you have to understand it yourself. But here I am hinting you what I'm asking in this problem is the number of local extreme points is equal to what? So in other words, I am asking you what are the these kind of things, troughs and crests. I'm asking you about the total number of these things that appear in the graph of the function. Yes? Okay, so, but the algorithm, hopefully you know. If I want to know the local extreme points, this algorithm is not useful. So which algorithm is useful? Either the first derivative test or the second derivative test. And be flexible. Let us see which one is suitable when we start. I cannot a priori judge which one is better now. Let us do that. But one thing I know, I need the first derivative. But this is not what you know in Ma3c, because that is the product of 2 functions. But this is the old lesson. The function is what? This is right. F of x is equal to x to the power of 3 minus 4x multiplied by x to the power of 2 minus 4. So let me see if I'm recording the correct one. Yes. So here, if I want to start differentiation, I have to prepare it for differentiation. In Ma3c level, it is not still prepared. So I have to get rid of this product. So the first thing I will do is to open it up. So multiply x to the power of 5 minus 4x to the power of 3 minus 4x to the power of 3 plus 16x. And please watch my calculations. If you see a mistake, please immediately tell me. Thank you. Are you okay with this? But we can simplify it a little bit because these two terms can be simplified a little bit more. So I would write this minus 8x cubed plus 16x. Okay, we need, everything is now prepared for differentiation, so I differentiate it once. F prime of x is equal to what? 5x to the power of 4 minus 24x to the power of 2 plus 16. Okay, what is the next step of the algorithm? It doesn't matter. If you want the first derivative test and the second derivative test, it is inevitable. You have to put this equal to 0 and solve it. And all of them are acceptable this time. There are no intervals involved in the problem. So how can I do that? I have to solve it, but I don't know how many of you can solve it. I actually intentionally gave it something like this because this is a Ma3c, but of course the degree is 4. The degree 4 and the degree 2 appear. Okay? So this is one stand. I'm not sure. I think I also gave you some examples of this type when I was teaching you in chapter 1. But in principle, you know that you have to solve this equation. Okay? The tricky part of this problem is to remember. I wouldn't say you should be creative here, because this is something you already studied. Okay? Yes, you want to say something?
No, I want to say if you could use an auxiliary variable.
Auxiliary variable. There we go. So it means that I think this is the name that I usually use. Probably I have covered this then. So I would say what? What is your auxiliary variable here? Let what?
X squared equals t.
T, for example. Yes, why? Because if I take this one, then if I ask you what is the name you can give to x to the fourth, it's just simply t squared. And then you put them back into this equation. Instead of having fourth degree equation, then you will have only second degree equation that you know how to solve. Yes? So what happens? It becomes 5t squared minus 24t plus 16 equals to 0. I would really prefer to, I don't know which one you prefer. Do you still want to use PQ formula? Because if you want, you have to divide by 5 and work with the exact values. Might be PQ is also good. Let me just use PQ formula. I divide by 5. Okay, and this is my P, this is my Q. What is the formula? So X is, let us do it in our head, minus P. P is minus, there is a minus in the formula, so it becomes plus. And then this number divided by 2. Can you do it in your head? 24 over 5 divided by 2. It's just simply what? 12 over 5, yes? So let us write 12 over 5 here. And then plus or minus a square root, whatever this number is, raise it to power 2, which becomes, I have this in my memory, 144, and hopefully you have this one at least in your memory, 25, yes? And then minus q. Oh, we are in trouble. Yes?
Why did you do 12 over 5?
No, that one is correct.
Shouldn't it
Might be
be
this and this is not correct. What?
Shouldn't it be 24 over 5 to the power 2?
No.
Okay.
This number to power 2. The formula is minus p over 2 plus or minus the square root of p over 2 squared minus q.
Oh, you did the whole thing yet to the power 2.
Yes.
Sorry.
But the point is, I am in trouble because...
Isn't it just minus 16 over 5?
yes, it is. Okay, so this is a very ugly number then. Might be that was not my intention. Okay, so might be this is why. So did you check my calculations? Yes. Yes. Okay. So let us calculate this. It's not a bad number. So if I want to calculate this, what should I do? I have to make the common denominator. So I have to multiply this by 5 and this by 5. So this by 5 is 80. And 144 minus 80 is 64. So it's not that bad. 64 over 25. Yes, but that is 8 over 5. So this becomes 12 over 5 plus or minus 8 over 5, so I have two answers. One of them 12 plus 8, 20 divided by 4, so t is what? Sorry, 20 divided by 5 is 4, or t is what? The difference between them divided by 4, which is 4 over 5. Is that right? Yes.
I think an easier way to do it without GQ would be if you could take the 24x squared and make it into 20x squared plus 4x squared, and then factorize the two. So
Yeah, factorization is simpler. But when I am teaching this here, I will not go through those things because factorization is not something people always remember. But my assumption is people have to remember at least PQ formula. So when I'm solving this, of course, if you do it in the exam way and it is correct, it's correct. Yeah, you do it in faster way. Okay, but at least can you confirm my calculations? Do you see any flaws there? It seems to be right, yes? 12 plus 8, 20 divided by 5, 4, yes, that's correct. But be careful, this is t, not x. Yes? I am looking for x. So I use t, I found t, I put it back here to find x. Yes? So if t is 4, what is x? X squared is 4. So what is x? Plus or minus 2. Yes? But there is another alternative for t. T is what? 4 over 5. So what is x? X is what? Again, plus or minus 2 over square root of. So how many numbers I got? I got 4. But you cannot immediately jump to the conclusion that there are 4, unless you want to take some risks, you know? For this question, if you just write 4 and the 4 is the correct answer, you will get all the points. Okay? But I think I want you to understand, not just memorize. You know that these are still not guaranteed, to be honest, to be the local extreme points, yes? Because some of them might be a fake one. What do I mean by a fake one? It means that they are what? Terrace points. Or what was the other name that they use in national exam? Saddle points. I want you to remember, saddle is just a saddle you put on a horse, and yes, the saddle point. Okay. So how should I? Now from now you have two algorithms. Either you can use the long one, the table one, okay, or which one? The second derivative test. I don't know which way you prefer. I myself prefer to do at least one trial to see, because this is not hard to take another derivative, yes? If you are in Math 4, you will have more complicated functions. Then might be the second derivative is also not that easy to calculate. But for Ma3c, you have only these type of functions. So let us test. I will take the second derivative here. Are you following what I'm saying? Here we have two algorithms, yes? Either you have to go to the first derivative test. It is longer, but it is guaranteed to work all the time. But I have another one, it's a little bit shorter in Ma3c, but there is a chance that I will not be able to answer all the questions. Yeah? Okay, I cannot probably understand this. But let us see what are the chances. So f double prime is very easy to calculate. So it is what? And that one is what? Okay, and I really recommend you, if you want to do the second derivative test, you just want to know if f double prime is positive or negative. I recommend you, if the factorization is so simple, do the factorization. Okay, so for example, between numbers I can factor 4 out, and between x, 3 and x, I can factor x out. So what's left for me? 5x squared is left minus 12. And always double check. Multiply this back, that's correct. Multiply this back, that's correct. Okay? And now, you see that this is not that hard. For example, let us calculate f double prime at, by the way, plus, or, okay, let us not jump ahead. Only, so I have to check 4 numbers. Plus 2, minus 2, plus 2, square root of 5, minus 5.
So f double prime of 2, is it positive or negative? Very simple. You don't need to calculate the numbers. This part is positive because you put 2 there. And then if you put 2 here, it becomes 4, 20. This one is also positive. So this one is positive. We don't care what the number is if the number is big. And this one is also positive. And I am multiplying them. That's why I ask you to factorize. Factorization is multiplication. So what is the answer? Positive. Yes? So this one is give you a minimum. If the second derivative is positive, that point corresponds to a minimum. Okay, can you tell me what happens for f double prime of minus 2? If I put minus 2 here, this will give me the same number, but this becomes negative. So positive times negative is negative. And this is what? The maximum. And then I go to the other two numbers. You see, this factorization is very simple now. I hope that we are lucky. You think we are? Usually life is not that beautiful, but okay, so I think it works. So if I put 2 here, 4 is positive. This one is positive. So far, multiplication is positive. What do you think here? You go to a scratch paper, because this is not hard. If you raise this one to power 2, what happens? It becomes 4 over 5. You multiply it by 5, and then you subtract 12. This one and that one are gone, so it's negative. This part becomes negative. This part becomes positive, so multiplication, negative, so it means this is also a max. And then, of course, we are lucky now because the next one, can you guess what will happen for the next one? Because this power of 2 is not sensitive to plus or minus, so it remains negative even for this case, but this one also becomes negative, so it becomes positive. So this one is minimum. But this is necessary. I mean, the person who just wrote 4 and the person who did this and then wrote 4 in these kind of questions will be assessed and evaluated at the same level. But the understandings are different. The person who did this one and then wrote 4, they understand what is going on. Okay, but the person who designs the questions, they have to be careful not these things happen. Okay? So I could sit down probably and design a question if that one of them is a fake one. And then that person will be in trouble. So I will try to do that in the exam, so don't take the chance before doing it. Any questions here? So what I will choose there, should I write 2 there or 4 or what? Because they are asking about local, what they are asking? They are asking about local extreme. When they say local extreme, it means either max or mean. So 2 of them are max, 2 of them are mean. So in total, I have 4. So what you have to write here is just 4. Any questions? Okay, let us go to the next problem. The local minimum value of this function is equal to 5. The value of the local maximum of f is what? So they have given you a function. You see, one thing in that function is not given to you. But instead of giving a, they have given you one piece of information that the minimum value of your function is 5. Based on this piece of information, they are asking you, okay, what is the maximum value? What is the local maximum of f? Again, means value, okay? So think about it if you haven't done that before so that I have time to clean the board, okay? So this is the question you are supposed to answer. So do you have any suggestions for me? How should I do this problem? I mean, these problems should be at least understandable by just first reading. You see, a function is not completely given. What is missing? A. In that function is missing. So A is one unknown. Okay? And they have given you something. Local minimum value is 5. So this is one piece of information. So the logic is to use this piece of information to find your unknown. This should come to your mind in a matter of seconds. This is the way you have to think. I'm not saying that if you succeed to think in this way, the problem becomes extremely simple. This is still a problem, but you know what to do. a function, you should, when you see this function, if you are good in math, you immediately realize that this is not the whole story. I cannot claim that I know my function because there is one missing piece in that function. How many missing pieces you see in that function? One. So how many pieces of information in principle you need to fine-tune that? One. And is it provided? Yes, it is provided not like an equation, it is provided by an English sentence. The local minimum value of the function is 5. This is just conveying a message to you. That's a piece of information. Okay, so this means that you, first of all, don't jump to see what should I do here. Use that piece of information to actually find that missing part. So how can I do that?
To find the x at the local minimum value, you won't need a because you can do the derivative of that.
Yes, this is the first thing. So you know, you can just go and review what you have in mind in the lesson for local max and local min. You have two algorithms, the first derivative test and second derivatives. Both of them needs the first derivative. So let us do that. If I do the first derivative, what happens? No matter what a is, it cannot survive. So the answer becomes 3x squared minus 6x. Yes? And then what I put this on equal to 0, what happens? It becomes what? It becomes 3x squared minus 6x equals to 0. And then you get, factorization is simpler here. What answers you get? 0 or 2. Okay, so one of them, if the problem is stated correctly, there is no fake one. Can you tell me why? If I trust the designer of the question, there is no fake one. There is no terrace point here. Why? Because you see two candidates. In general, one of them might be a fake one or two of them might be fake ones, yes? But according to the structure of the problem, if you can't trust the designer of the question, it means that there should be a local minimum because they have given you this number, and they are asking about the local maximum. If the maximum does not exist, they usually shouldn't ask this question. So it means that somehow you understand that none of them is a fake one. But which one is which is important. I need to know which one is responsible to maximize and which one is responsible to minimize. Okay? Which one you prefer? Here you have two algorithms. Either you can go to the first derivative test or you can go to the second derivative test. Second derivative test, by experience, is simpler and you don't lose that much time. So let us do it, especially for this case that the second derivative is extremely simple. Yes? Is that right? And then I calculate the second derivative at those numbers, 0 and 2. The only problem is that I am so unfortunate that one of them or both of them turns out to be 0. Then I am in trouble. Then I have to go back and do the first derivative test. But here I am lucky. If I put 0 here, it becomes minus 6 negative. And then if I put 2 here, it becomes 12 minus 6, which is 6 positive. So this one is maximizer. This one is minimizer. Because if the second derivative is positive, it corresponds to a minimum. And if it is negative, it corresponds to a local minimum. Okay, but they are talking about minimum value. When they say local minimum value of the function is 5, what does it mean? It means that if you find the minimizer, the number which is responsible to make the minimum, into your function, the y coordinate becomes 5. Do you remember? I told you that when you have a max or mean, you have two coordinates. When they talk about the value or just simply local minimum or local maximum, they mean the y coordinate. So, local minimum value is 5. Which one is responsible for minimum? 2. So it means that if I go to my original function, replace x with 2, the output is supposed to be 5. So I will do that. I go to my function, replace x with 2. The answer is supposed to be 5. And this is just, I told you, this piece of information helped me to find the unknown. How? This is just 8 minus 12. So A is what? 9. Yes? If A is 9, the only missing part about my function is found. F of x is equal to x cubed minus 3x squared. Instead of A, I put right 9. But what is the question mark now? The question mark is about the local maximum value. So what should I do? I have to find the responsible for the maximizer. I already did. The responsible for maximizing my function is 0. They are asking about the y value of the local maximum. What should I do? I have to replace 0 here. So the answer to the question mark is what? Understandable? So this question is an A-level question. Again, not because the algebra is hard, but if you really can wrap your mind around that, it means that you have a deeper understanding of the concepts, and then you deserve a higher grade. Yes?
We can't use the first derivative test, right?
We can't.
Because we don't have A.
No, we don't need A.
You don't?
You know why? Because even in that table, yes, you cannot calculate these numbers in the table, but you can recognize which one is max, which one is min, which is enough for the first part of the problem. So you see, you have the numbers 0 and 2 here, and these numbers are 0. I agree with you. First, we cannot calculate these numbers. These numbers depends on A. Yes, for example, if I put 0 there, here it becomes A, and if I put 2 there, it becomes what? 8 minus 12 minus 4 plus A. I agree with that. But the first part of the problem, this is not important for the first part. The important thing is it positive or negative? And that has something to do with the derivative. If you do this, these random numbers, this becomes plus minus plus. Okay? Then you understand that this point is a maximum point. Yes? And this point is a minimum point. So when you say it is a minimum point, this is the value of the minimum. So this means that minus 4 plus A should be equal to 5. A becomes 9. And then you put it back. So yes, this is working. But it is just making it longer, which is not necessary in this problem. Okay, so if I go back here, so what I put here is just number 9. Any questions? Understandable? Okay, so the next question. The function, this is given and it is mentioned, it is concave down on this interval from A to B. A and B are not given. We want to find the maximum of B minus A. In other words, I want to find the longest interval on which my function is concave down. Yes? Do you understand that? For example, this function, let us say that I have this kind of function. Okay? If I ask you, if I concentrate on this interval the function is concave down. But this is not the longest one. For example, if I go a little bit longer, still the function is concave down, but this is a longer interval. So in this problem, they are asking you about the longest interval on which the function is concave down. It means that if you go a little bit to the right or a little bit to the left, the function will no longer be concave down all the time. Okay? But you shouldn't be distracted by these things. So if I see this problem, in a matter of seconds, I know what to do. And you should also be able like, because this is not a very high level math. What do you think? You say that, okay, I have to find something in the lesson which relates to concavity down or up. What was that thing? Second derivative. So that's it. So when I read the question, I see that I have a function and I am talking about concavity. So I just need to remember, that's the role of memory, that which part of the lesson is related to concavity. And if you don't remember, of course you are in trouble. But if you remember, then it means that this is the second derivative. So this will give you a strategy. So now you're momentarily, how do you say, your temporary strategy is what? To calculate the second derivative. And then you have to train yourself like this. You know, humans are always thinking about the future, what's going to happen in the future. It's a very hard thing to live at the moment. Now, when I understand that I have to find a second derivative, for the time being, I am happy and I'm enjoying the life because I know I have to take the derivative. Yes, after that, God is great. What something will happen. Okay, so let us at least pass this. Then it is very good to think in that way. Yes, because if you're stressed, oh, okay, what is this? What is coming next? What is coming next? Who knows? You might have a heart attack and you are dead and you have joined to the heaven before the end of the question. Yes, so don't worry about that. You just need to know that, okay, I have a strategy. The strategy is to take the second derivative. And by the way, for the second derivative, can I jump to the second derivative? You see how many things you have to think about before thinking about dying or something like that, you know? You have to do the first derivative because your goal is to do the second derivative. To do the second derivative, you know that you need to find the first derivative. To find the first derivative, you know that in Ma3c you usually need to prepare the function. Okay? So let us do the preparation, let us see what happens. Okay, so this is the mentality it's good to have. It's not easy, but it is good to have. Okay, so yeah, for example, right now I'm teaching you. I'm not thinking what's going to happen after this class. Okay? I'm just teaching and I'm enjoying this process. You should also enjoy the process of differentiation now. Okay, so what is your function? Function is f of x equals to x plus 3 multiplied by square root of 3. So your strategy is clear. Second derivative, this strategy goes through this. This strategy goes through preparation. Yes. Don't kill me, yes? Preparation. Preparation, is this A? Prepare, yes? Something like that. So preparation. So you see now you are in this stage. After that, first derivative. After that, second derivative. After that, God is great. Let us see what happens, yes? So we do that. F of x is equal to what? X times the square root of x plus 3 square root of x. Is it completely ready for preparation? Is it prepared completely? No. Do you remember? You need to remember something. Square root of x is not very useful, so you have to prepare it. Then you need to remember something. So you see what is the role of memory? It is extremely important every time I am using my memory. Otherwise, I will not be able to solve the problem. So square root of x is x to the power of 1 half. So put it back here. Okay? Can you do this part in your head? Multiply this by x in your head. X to the power of. This power is 1. This power is 1 half. It means x to power 1 plus 1 half. It means x to power 3 halves. Okay, at this level, you should be really quick in these things. Okay, and then this one, x to power 1 half. Is it prepared? Yes. So this one is done. Now I go to the next stage. Okay, so you see you are going higher. This is very good. Usually I have to start from up and down, but this is a better way. Yes, you go higher, and you get closer and closer to God. Yes, then you need to ask, okay, what can I do later? Then you need to get some help there. So, what can I do now? F of x, f prime of x is equal to what? These 3 halves goes down. X to the power in your head. What's the answer? 1 over 2. And then this one, tell me. No, first of all, you need to bring 1 half down, 3 halves, and then x to power 1 unit less. 1 half minus 1 is? Minus 1 over 2. Yes? Okay, this is preparation finished. Differentiation is finished. But be careful, because you want to go to the next step, you have to think, is it also prepared for the next step? Yes. So, some of you might jump to simplification immediately, which is not good, because if you simplify, for example, if you write this square root of x, it is not good, because then you want to have another derivative, then you have to go back and write it as this form. So it is already prepared for the second stage. So immediately do that. So let me write it here down. So what happens here? F double prime is what? 1 half goes down, so it becomes 3 quarters, x to each power in your head. minus 1 half. Next stage, this one goes down. What is the number? Minus 3 over 4. X to power 1 unit less. Minus a half, minus 1 more. Minus 3 halves. Yes? This is the second derivative. Okay, now this is good. Our strategies are finished. We have to come up with a strategy. At this level, some novice students forget about why they are doing this. Okay, why we are doing this? Concavity. The problem was concavity. Yes, it means that you should remember why did I do these things which I did. Many of the students I have seen by experience, when I explain, they come with me and then they forget why we are doing them. Okay, why we are doing it? Because we want to talk about concavity of the function. Okay, then you need to go again remember. So what is the relation? Why we did this? Because I wanted to find the second derivative. Now you need to remember a piece of lesson. Why second derivative is even useful for concavity. Less than 0. Concavity down means second derivative negative. Concavity up means second derivative is positive. I want to make concavity down according to the problem. So demand is what? This is my demand. What is my demand? The second derivative should be negative. Okay? But the second derivative, negative, is ugly. It's not a good second derivative. Where is it? It's hiding. Yes, here. This is not a very beautiful second derivative. Okay? So you have to make it beautiful. Okay? By the way, you know that, for example, in Princeton University, one of the most prestigious universities about mathematics, if you are graduated from mathematics department, your degree is the degree of art. Okay? And that makes sense because mathematics is like an art. For example, not everyone enjoys like classical music, but the people who are enjoying the classical music, they are not ready to listen to any other music. So that's more or less like mathematics. So that is kind of an art. So you have to be able to simplify this because this is so ugly. You want to make it more beautiful. How do you make it more beautiful? Yes. Why ugly, by the way, these are philosophical points. Is this ugly to my human eyes? Yes. Because we are in trouble working with negative fractional powers. Yes? So it looks ugly to us. So let us remove this problem. How can you remove this problem? If you look at the problem in this way, you value it, and then you will enjoy it. When you enjoy it, you will learn it. These are the ways that I thought about the problem. I didn't like the form. Okay, so I learned this once for all, yes? So how can I solve the problem? I need to get rid of this. How do I get rid of this? There is one single rule for it. To make it positive, yes? And then this one is also still ugly. Is I can. So this one is better. What about this one? Can you fix this one for me? Yeah, this you see you learned. Because you valued beauty. Okay? If you don't value beauty, it doesn't matter how many times you repeat this, you will not see that. Okay? So, but there is a problem here. How can I fix this one if I want to go back to this third sign? This is not third root. You need to remember something. What was that? A to power m over n is equal to nth root a to power n. Yes? So I will write it as 1 over. Second root is not written by convention, so it is x to power 3. But x to power 3 is also can be done something. So a square root of x cubed can be written as a square root of x squared multiplied by that, but this one is just simply x. So I prefer to write it in this form. Okay? Okay, so now f double prime is equal to, finally, can you write it in a better way? By the way, 3 over 4 and 3 over 4 are the same. So, are you motivated to do something? Yes? You see a 3, 4, this is a coincidence. Okay? 3 over 4 appears here, 3 over 4 appears there. And my goal is to somehow simplify things. Do you think that I will do something here? Because this was not something I could see a priori. I can see that they are the same, so I factor it out. Okay? So what is happening here? Instead of this expression, I can write this. And instead of that expression, I write minus 1 over x squared root of x. Do you see that? Yes or no? There are many things that you can do here. I don't know which one you prefer. For example, can I factor things more? Do you see that I can factor something out still? 1 over square root of x also appears here. So I can pull this out as well. And from here, 1 is left, from the other one is this left. Yes? Okay. So I would say that let us stop here. Let us stop making things more beautiful. Okay, so here. And now the question is that, why did I do this again? What was my demand? I want to make the second derivative negative. So this means that I want to make this one negative. This is again my demand. This is not a standard problem, I know. I don't know, for some strange reason in Sweden you do not solve a little bit harder inequalities. So that is why when inequalities comes in your way, you have to be more creative. So you want to find all x's for which this product is negative. Okay? But this part of the product is always positive. Because a square root of x, the output of a square root is always positive. It cannot be negative. So 3 over 4 is positive. The square root of x, the output of x. Not only I have to respect to put positive numbers there, but if I do respect and put positive numbers there, the output is also positive. So this one is definitely positive. Yes? But my goal is to make this one negative. Yes? That's it. Because I want the product be negative. I am sure this part is positive, so this part should be negative. So when you say that part should be negative, this is what you mean. Okay? Is that right? So in other words, you mean 1 is less than 1 over x. Yes? So can you tell me what should I write there? I want to choose all x's so that 1 over those x's are negative. X is less than 1. Do you agree? Because you see 1. So if might be for me, my brain works the other way around better. I don't know why. 1 less than 1 over x means 1 over x greater than 1. That's the same meaning. So answer the question again. You want to choose all x's so that 1 over those x's become greater than 1. For example, is 2 acceptable? No, because 1 over 2 is 1/2. It is not greater than 1. Is 3 acceptable? 4 acceptable? No. So no numbers after 1 is acceptable. Even 1 itself is not acceptable because 1 over 1 is 1 and 1 is not greater than 1. So no number after 1 is acceptable. So the only candidates that come to my mind is the numbers below 1. Do you agree? So this means that if, by the way, you have to check that one. If x is less than 1, 1 over that number automatically becomes greater than 1. Yes? Okay. Now I want to see how many of you understand what we are doing. Okay? So this is the end of the calculation. The calculation is finished, but the conclusion is coming out of this calculation. And I wanted to go back to the question. If I go back to the question, what do you answer finally? I'm waiting for you. Every piece of information that you need is on the board. This is the hard part. You have to have a good knowledge to be able to interpret this question. Okay? So I solved this and I got this number. It's a little bit, you know, it's like politicians' answer. It is true, but in the meanwhile, it is a lie. Okay, this is the way politicians say something. They say that okay, this is you people believe them, but they are not showing the whole truth. Okay, so that is why I want you to go back and solve this problem now. If the answer is this, okay, what do you answer for this question? What should I write here? If you can trust the politician who told this to you, try to sell this answer to you. By the way, it is very reasonable. What I did, so that's why I want you to learn critical thinking, you know. What I did is completely, everything is legitimate. None of them is a lie. The conclusion is a lie. Yes? Yes, can you tell me, if, let us trust the person who told you this. If you trust that person, what do you write in this box? So you have a bigger problem. Even if you have trust to the person, you don't know what to write. Just read the question. Yes, Yoshi?
I think because...
No, give me a word. Okay, don't answer me in a politician way.
No.
Just give me one word. I want to put it there.
One?
No, okay. One is not the case. No, one is the answer, is the honest answer. No, let us say that based on this, if you just based on this, what you're supposed to write here. Yes?
B is equal to 1. So I'd say A does not exist because everything under X is included.
Okay, yes, you are on the right track. Can you say that what can I write finally? A reasonable word there. By B minus A is equal to? So you told me that what is playing the role of B? 1. So B 1 in your head. What is A?
0.
No, you know it is 0. Forget about that. Just X less than 1. Yes?
I'd say B minus 2.
No, B does not exist. So it means that this word, now this is what I want you to tell. When you say this, it means X is from 1 up to minus infinity. Yes? That is what you are trying to say, and it was correct. Okay? And then when I say what is B minus A, what do you say? B is 1. Yes? Minus infinity. So it becomes what? Infinity. And that is right, because if you just trust this one, what is the length of that interval? It starts from 1 up to minus infinity. What is that length? Infinitely long. Okay? But of course, this is not the correct answer. Now I want to tell me what is the problem of this answer. Why this answer is not correct.
Because you cannot include 0.
Can you elaborate more?
Because you cannot divide something. No.
Okay, but why? Because you cannot come up with some strange stories. But can you tell me why now the answer is 0?
Because
Why do you prefer? Because there is, I want you to understand, this equation tells you 1 and before 1. By the way, are negative numbers are also acceptable, or are they lies? No, they are acceptable. Okay, are they lies or not? Yes? If I put, you see, I said less than 1 and I didn't show you the whole truth. If I choose negative 1, for example, negative 2. Negative 2 is still less than 1. But is it a correct solution? Because if I put minus 2 here, it becomes minus a half. Is minus a half greater than 1? No, so it was not the whole truth. I did it in a way, this is called illusion, yes? You got this illusion that this is the correct answer, but that is not the correct answer. Yes? Because if you choose negative value, 1 over a negative value cannot be bigger than 1. So this means that this is not the solution to this innocent inequality. You have to make sure that this is up to 0. Okay? So that is the mistake. So I did everything correct up to that point, and then I just used your innocence to say that the answer is less than 1, which was part of the truth. But I didn't tell you that you are not allowed to go beyond 0, because if you go beyond 0, you will get a negative value. 1 over a negative value cannot be greater than 1, because that's negative. So this is the correct answer. There was also another way to see that I have that one, because a square root of x does not make sense if you go beyond 0. If you go to the negative values, this part is not making sense. And even my function does not make sense, you know. If you have this function, implicitly means x is greater than or equal to 0. Because if not, the function is not a function anymore. So nothing will actually work if there's no functions. Okay? So be careful. This is the correct answer. So this will play the role of A, this will play the role of B, and the question is asking you about B minus A, yes? And that is 1. And by the way, the question is asking about the maximum value. You understand that you are not allowed to go beyond 1, you are not allowed to go below 0. So this is the longest one. And that is exactly the one that we want to answer in the book. Okay. You know, I am using these things because I want you to understand that if you really want to understand all the details in a mathematics problem, you have to be very careful. You have to be conscious all the aware of yourself, conscious all the time. Okay? So that is why mathematics is sometimes hard. Because you know, everything I did was 100% correct, but I was so careless at the very end. So I lost my consciousness for 1 second, and the problem was answered wrongly. Okay? Yes?
What I just thought of was 1 over 0 is undefined. That's why I kind of wrote it.
No, that is not a good analogy. That is not a good reason, even though the answer you got is correct. Yes? Yes. Of course, I agree with you. 0 is not acceptable because I see 1 over x. But it doesn't mean that I have to stop. I could exclude 0. Yes? But it doesn't mean that I have to exclude every number below 0. For that one, I have a better reason. I should have a better reason. Anyway, any questions here? Yes?
Sir, how would you motivate this one? You motivated it with words, but do you want us to write something in
No, this is why I'm saying that. In Sweden, they don't study inequalities. So studying inequalities, we cannot solve them like this. I have to move them to the left, and then write it as a fraction, and then say when the fraction is positive.
Okay, but...
Yeah, so because if I don't want to go through it because we will not have time. If you want, you can come back to me. We in Sweden, for some reason, we do not study these inequalities systematically. So then you always come up with inequalities that are simple in form that you can analyze just out of your brain. No, that's why you don't expect hard inequalities. Okay, so let us go to the next problem now. Consider the following figure. If this figure portrays part of the graph of this function, what is a plus b? So this function is given to you somehow. You see what characteristics you see. You see a minimum, extreme minimum point and a terrace point. Okay? And then I want you to understand there are how many unknowns in your function? 2. This is the way I think immediately. When I see this problem, I see how many unknowns are there in my function? 2. Then it means that I understand how many pieces of information I have to extract from the problem? 2. Okay? Then I have to think. For example, one of them is this number. The other one is this one, which is a terrace point. I try to use as much as I can. Okay? So think a little bit about this so that I can clean the board. A rough graph of it. So we have this thing. we have a function of this type. So everyone understands that by this I mean a terrace point, which I don't know how much is that. I know that this is just a terrace point. This is a local minimum point, and I have given you the x coordinate, and the function f of x is given to be 1/4 x to the power of 4 plus ax cubed plus bx squared plus 2. And then what is wanted in the problem? A plus b is wanted. Okay. Can you tell me what should we do here? So you know that how many pieces of information are missing? 2. And I want to have a plus b. Okay? Be careful. Sometimes you don't need to find a and b separately because they don't want a and b separately. They want a plus b. In the harder questions, might be you will not be able to find a and b individually to be able to add them up. Might be you just come up with some miraculous way of doing things with a plus b itself. But that is not the way that I think, at least for the first time. I will try to find 2 pieces of information from my figure and use those pieces of information to find a and b. And when I have a and b, of course I can add them up and answer the question. Okay, can you tell me what pieces of information you find this relevant? So one thing should be very easy. If I ask you, can you tell me what is 3 according to this picture? Yes?
Local minimum.
No, be very careful. What you are saying is correct. 3 is not the local minimum. Local minimum is this point. 3 is the x coordinate of the local minimum point. Okay? Do you remember last time I told you, I gave you a table. So I told you that if you know alpha and beta, it is a local minimum point. Do you remember how many pieces of information this will provide for you? That table was very important. Very important. Please make sure that you have that table. Alpha and beta is a local minimum point. There were 2 pieces of information coming out from this sentence. One piece of information is f of alpha is beta. This is one piece of information, which is not useful for my problem. Why? Because this needs alpha, which I have it, also needs beta, which is this one, I don't have it. So apparently this is not useful. But there is another piece of information I wrote here for you. What was that? What? F prime of alpha is 0. Is this one useful? Yes, because alpha is given to me. So I take the derivative. F prime of x is equal to, what is the derivative here? 4 goes down, x cubed. 3 goes down. And then this one, 2 goes down. Do you agree with me or not? Yes? Okay. And then f prime of which number should be 0? Alpha is in this problem 3. So this means that this should be 0. It means that if you go to f prime, replace every x with 3, the output is supposed to be 0. I did that. So let me simplify that. So this is 27a, this is 6b, and this is 27. I move to the other side. For simplicity, I divide everything by 3. This is one relation. Okay? By the way, this is part of the problem. So if there are 2 points for this problem, you already receive 1. That's good. Okay. So you see, you shouldn't work on this anymore, because if you remember what I told you, that table is extremely important, that summary that I gave you last time. There are only 2 pieces of information that you can extract from a local minimum. One of them is not working in this problem because you don't have access to this y value. One of them works. So this give up. There is nothing more you can extract from here. Okay? So this means that this, I don't even look at this part anymore. Which part is relevant, do you think? The terrace point. Then you have to remember how many pieces of information a terrace point gives you? No. That was exception 3. Okay, so let me write. Alpha and beta, a terrace point. How many informations are there? Can you review this? 1, 2, and 3. What was 1? F alpha is equal to beta. What was 2? F prime alpha is equal to 0. Don't miss it, because even in the terrace point, the tangent line is horizontal. But there was one more. F double prime. Okay? So this is the way you need to think. A terrace point gives you 3 pieces of information. Is this one useful? No, because I don't know beta here. So this is not useful, doesn't mean it is wrong. It's not useful. Is this one useful? Maybe. How should we know that?
You add 0 to
It automatically becomes 0. So but you have to test. What is alpha? Can you tell me what is alpha? Alpha is the x-coordinate of the terrace point. I have access to the x-coordinate. What is the x-coordinate of the terrace point? 0. So I know alpha. So this might be a relevant piece of information. This also might be another relevant piece of information. But you see that this relevant piece of information is automatically fulfilled. It will not give rise to anything useful. Why? Because if I go to my derivative, replace alpha with 0 here, the output is automatically 0. So this means that this condition is always guaranteed, independent of what A is or what B is. It is always satisfied. So it will not help me in this problem, even though it is true. Is that right? Okay. So there is only one piece of information that might be useful for this problem, and that is f double prime of alpha equals to 0. So then it means that I need my f double prime. So what is the answer? So I want you to understand the logic. It is extremely important. It doesn't mean it is wrong. It means if it is wrong, I am in trouble. It is not wrong. It is automatically satisfied. Okay? Which is not useful for me. So here, can you help me now? F double prime is this guy. If I replace it with the x-coordinate of the terrace point, the answer should be 0. So let us do that. I replace x with the x-coordinate of the terrace point, which in this case is 0. Yes? This is f double prime of alpha. It is supposed to be equal to 0. But this means what? This means 2b is 0. This means b is 0. And when b is 0, I put it back in this. A becomes, this is 0. 9a is minus 9. A is minus 1. What is the question mark? The question mark is a plus b, which is minus 1 plus 0, which is minus 1. The answer is minus 1. So these problems, I will consider them still A level, but these are really manageable A level problems. Because creativity is close to 0. I'm not being creative here. I know the rules. I'm using my memory. Memory is not creativity, yes? It helps you to be creative, but that's not the whole picture, yes? So this is considered A-level question at the level of national exam, but you see that these are nonsense things, okay? I explained this for you. So the solution is just this. And it brings you 3 points, for example, okay? But you have to know how to analyze the problem. Okay, finally, let us go to the next problem here. The last one. Okay, if the inflection point of this function lies on the line y equals to 2x plus 5, what is A? Again, you shouldn't be scared of these kinds of problems, yes? Do I know my function? Yes or no? Do I know my function? No. Yes? Because A is missing. Train your eyes. A, do I know my function? No, because I don't know A. How many pieces of information is missing from my function? 1. A. How many pieces of information is given in the form of an English sentence? 1. The inflection point of this guy is lying on this line. So the piece of information is a long sentence, but this is just conveying one piece of information. It is telling you where is the location of your inflection point. Okay? So we want to solve this problem now. How do you think about the problem?
Use the information from the table.
What?
We can use the information from the table and we also know it's an inflection.
Okay, because I don't know. So let us go back here. Let us review these things. Last time I told you that if I give you alpha and beta is an inflection point only, this is two pieces of information. One piece of information is again f of alpha is equal to beta. You don't even to memorize this because every point on the curve should have this relation. Inflection point is also somewhere on the curve. But for inflection points, we need something more, yes? All is 0. Okay? But this formula is useful if you have your alpha. Okay, so let us go back to the problem. This is not exactly this problem because this is useful if inflection point is given to you. You remember I told you that the other way around is not usually correct. Okay? But do I see my inflection point in the problem? No. So this you shouldn't expect to be useful because this is useful if someone gives you here you are, this is your inflection point, then you can use this. But the inflection point is not given. That is up to you to determine the inflection point yourself. So this is not this algorithm. So you see, this chapter is always about algorithms, to choose which algorithm. Which algorithm is useful for this problem? Not this one. The one that I use to find my inflection point. Yes? How can I find my inflection point? So let me write my function here. F of x is equal to 2/3 x to the power of 3 minus 3x squared plus what? ax. How can I find the inflection point of my function? That algorithm is useful here. What was that? The first derivative, it becomes 2x squared minus 6x plus a. The second derivative, it becomes 4x minus 6. The second derivative equal to 0. So this gives me what? Okay? But be careful, I want to do it properly. Can I be sure that this is the inflection point? Because we might also have fake ones. So when you put the second derivative equal to 0, you get a number. That number is a candidate for the possible inflection point. Inflection point is real if the second derivative changes sign. Do you remember that algorithm? But because this problem is telling you there is an inflection point, if otherwise this problem is wrong. And how many candidates you got? 1. If this is the fake one, it means there is no inflection point. So based on the problem, we can trust that this should be an inflection point. But if I really want to test it, do you remember how should I test it? So let us review things because you know if you improve your memory, you will be a mathematician. I'm sure you can be better than me. But unfortunately, your weakness is in your memory. Okay? So, x is 3/2. The second derivative is 0. Do you remember? If I want to know the second derivative is positive or negative, I pick a random number. I told you this is very close to the first derivative test, but the middle one is f double prime when it comes to inflection points. So a random number before 3/2, let us choose 0. And I put 0 in, this is f double prime row. I put here, it becomes negative. A random number after 3/2, which one is good? 2. I put it here, it becomes positive. So concave down, concave up. So it is a real one because the second derivative changed the sign in the passage of that point. Okay, that is confirming that be careful, yeah, be relieved. This is indeed the inflection point, not point, the x coordinate of the inflection. Okay, okay, so this is the x coordinate of the inflection point, but what is the y coordinate of the inflection point? I have to take it back and put it where?
Second equation.
In,
The second function.
no, I will do that, but no, I'm just asking you, if I give you only the function and I want you to find the inflection point, you do this process, you get the x coordinate, and what do you do after that? You put this one in your function because you want to find this number. This is f. So I will do that. So this is my function. I put this number back into my function to find the y of inflection is equal to what? 2/3, is that right? Is that function? Yes, 2/3 x to power 3. What was my x? 3/2 to power 3 minus 3, 3/2 to power 2 plus a 3/2. Yes? Okay, let us calculate this a little bit. So this becomes simply 9/4. This becomes minus 27/4, and that becomes a 3/2.
No, you forgot the power tree.
What?
The power tree.
No, I did everything in my head. Yes, so 3/2 to power 3, one of them is cancelled, two of them are left, so it's 9/4. And this is 9, 3/27, and that is 4, and that's correct. So this becomes minus 18/4 plus 3a/2. Then it becomes minus 9/2 plus 3a/2.
Sir,
Yes.
isn't the 4 supposed to be 8?
Where?
In the second one, 27 divided by 4 shouldn't the
2/3. Yes. This one is what? 27/8. 3, 3, 9.
Oh, you multiply.
Yes, 2, 1, 4. Yes. That's correct. Yes. That's correct. So the answer becomes this. Now, if I ask you what is the inflection point, you cannot say more than that. You can say the x coordinate of the inflection point is 2, but what is the y coordinate? Is this number. 3a/2 minus 9/2. Okay? This is your inflection point. Do I really know my inflection point yet? No, because I don't know a. That is why they have given you one piece of information. They are telling you the inflection point is on this line. So what does it mean? It means that this point is on that line. Whenever a point is on a line, it means the coordinates of the point should satisfy the equation of the line. So what is my line? This is a line. According to the problem, the inflection point that I got it is on this line. So this means that the coordinates should satisfy this equation. So instead of y, I put this. Yes? Equals to 2. Instead of x, I put x. Yes? And then I solve it. For example, this 2 and that 2 are cancelled. So this is just what? 8. And because there is a 2, I prefer to get rid of fractions. I multiply everything by 2, so it becomes 3a minus 9 is equal to 16. I move this to the other side. 3a becomes 25. So what is a? Yes? Understandable? Okay. Yes, so what we are doing, let me also, I'm not sure if we can use in GeoGebra like this. So let me open this. If I want to do that, so what is, if I ask you find the inflection, I think Abdullah mentioned, yes, there is inflection point instruction here. What is my polynomial here? Can you show me? Can you read it for me, please? 2 what? Where is it? Where is my function?
2/3x cubed.
That one. Yes, please read it for me. 2/3 x to the power of 3, and then
Minus 3x squared
minus 3x to the power of 2
plus a.
plus a is x. Okay, I don't know why GeoGebra gives me an answer, but that's stupid. Ah, okay, that's correct. Now, because you know that GeoGebra cannot give you an answer, yes, because A is missing for GeoGebra, but instead GeoGebra actually does what? Does a point, okay? This is the point that you see is the inflection point of this function depending on what A is. This is why when I move this slider for A, that point is changing. Do you see that? They haven't drawn the graph. If you want, I can also draw the graph. Y is equal to 2 over 3, and then I have x to the power of 3, and then I have minus 3x squared, and then I have plus ax. You see? Do you agree that if I start moving this, you see this is happening, but that point is what? The inflection point. Do you see that? Okay, let me also type that function. Y is equal to what? 2x plus 5. This is also my line. Do you see that? Is this point on that line? No, but if I move it according to my calculation, 25 over 3 is the number making that happen. But 25 over 3 is outside of this slider. You see, it goes maximally up to 5. So just let us do this thing. So I go to the setting and I go to the slider and I change this default. 25 over 3 is approximately 8. So let us make it 10. Okay? And then I go backward here and then let us do that. You see, if I start changing this, the function is changing in a way, okay, but what happens? I go to 25 over 3. So you see, all the time this remains inflection point for different curves. If I increase it, at some point the inflection points will lie on that line. Do you see what's happening? Okay? Yes, let me just show it to you. That is my inflection point that lies on that line. And if you read this number is 7.95 here. But we know the answer should be 25 over 3. If I calculate 25 over 3, the answer is 8.3. So this means that is not precise, but that is what we are doing. Yes? So what we are doing is that we have a group of functions with different values of A, so we have different graphs. Every graph has an inflection point. Among all those graphs, I am choosing the one whose inflection point is on this line. This is what we have done, yes.
I think when below 7.95, that's the y value.
Pardon?
7.95.
Oh, yeah, that's the wrong one. Yes, you are saying the number on top is 8.3, that's correct. And this 25 over 3 is 8.3. So it means that when A is 8.3, this happens. Is that understandable? So that is what we have done. Okay, thank you very much. Bye-bye.